Okay, then it's a little bit different introduction. I would like to introduce my uncle, Luiz, who is going to give the first keynote. And I look very much forward to this keynote because as the first time I came here at UNICAMP, I met Luiz, and back then he already told me some of the ideas about the sustainable campus and so on, and it have grown a lot since then. So I really look forward to your talk about the energy transition in Brazil and what is being done of interesting work here. So please, Luiz.
So thank you, Bo. So I have 3 subjects. I hope I have time to everything. First, I'd like to give an overview about energy transition in Brazil, especially for the foreigners. Then I'd like to show a little bit what UNICAMP is doing to contribute to energy transition inside our campus, the Sustainable Campus Project. And if I have time, I'd like also to say a few words about CPTEM. It's the São Paulo State Research Center on Energy Transition. It's how UNICAMP is planning to contribute to this subject regarding public administration of the municipalities, of the state level, also in the federal level. So let's get started. Você tem que colocar lá o mouse. No. So in Brazil, we have a national interconnected grid, as you can see in this picture. So it's a very robust, very reliable, and very complex transmission grid, connecting almost the entire country. We have also some interconnections with Uruguay, Argentina, Paraguay, Venezuela. And you can see that in the Amazon region, we don't have this interconnected system. Just Manaus, the capital of Amazon state, was connected recently. So in this Amazon region, we have isolated systems for small communities, mainly using diesel. But in the rest of the country, we have this very big interconnected system, interchanging electricity from the northeast to the southeast and to the north and to everywhere. The red system, it's 500 kV. And we have long transmission lines. You know, Brazil is a very big country. We have 5,000 kilometers from here to here, 5,000 kilometers from here to here. We have also HVDC. This is more than 2,000 kilometers. This transmission lines in HVDC. I also have one here, more than 2,000 kilometers. And also have HVDC from Itaipu. This is the Itaipu hydro station. We have a concentration of a consumption on the coast, but especially in the surface, São Paulo State, Rio de Janeiro State, Minas Gerais State. And we have a concentration of generation in the countryside. This is the reason we have these very long transmission lines. And you can also see in this picture over here that we have rivers everywhere. Big rivers, medium rivers, small rivers. So we have a tradition on hydropower generation since the beginning of the electric sector here in Brazil. So in terms of energy transition, we have already a decarbonized matrix. You're going to see that we're in a very good position in terms of electricity matrix. Okay, let me try something. We have the rivers. Sorry about the... But sometimes we don't have rain. So this is what is happening right now in Brazil, in the north. We have a very extreme dry season. This is the Amazon River. In my life, I never saw a thing like this. Everywhere over there should be the river. So you have a very strong dry season in the north. On the other side, we have a very strong wet season in the south. I'll show you. There is another video over here. This is Itaipu Falls. A lot of rain, extreme rain, and floods in the south. A lot of people died this year. Itaipu Falls, you know, it's one of the wonderfuls of the world. And usually it's not like this, it's like this. But you can walk easily on these pathways over the falls, but nowadays this is the situation over there. Os brasileiros. Como é que a gente agora volta? So, because of this, we have also in Brazil thermal power plants, because to guarantee energy security, you need some dispatchable power plants as well. So we have thermal power plants using natural gas. We have 2 nuclear power plants. We have very few power plants using coal. Also have a lot of biomass. We have also a big tradition in biomass from sugarcane. You know, we have a very big program to produce ethanol from sugarcane in Brazil for many decades. I don't know if you know about this, but most of the cars in Brazil are flexible. They can run on ethanol, they can run on gasoline, and they can run with any mixture. So we have a lot of sugarcane bagasse also used to produce electricity. So if the picture, it's about 20 years ago, this is what we had in Brazil. A lot of very large hydropower plants. We have some thermal power plants using natural gas, using biomass, using nuclear energy, and a small part of coal. And for the isolated systems, diesel. But we have new inputs now. We have the climate emergency. And I just saw you the videos. So, and now it's the time to respond, the time to watch, to listen, to measure. It's in the past. So there are new inputs. So here you have this paradigm that big is beautiful. And now we have a new paradigm that small is beautiful. So in the last 20 years, we had this strong movement in Brazil. It doesn't mean that you should destroy our interconnected systems, our big power plants. It's not about this. But most of the new generation comes from small power plants using solar, using wind, also using biomass. So you have this generation everywhere in Brazil, and it happened very fastly in the last 10, 15 years. So with this new paradigm, you can use various small renewable sources everywhere, including small rivers as well. You can reduce the environmental impacts. You can attract small investors. And this is also impulsionates the development of smart grids. So this is what is happening for the last 2 decades. And if you look in our electricity matrix today, it's like this. We have 50% of hydro. We have already 15.8% of PV, 12.2% of wind power, 8% of natural gas, 7.7% of biomass and biogas, oil and other fossils, 3.9%, coal, 1.6%, nuclear, 0.9%, import, 3.7%. If you sum this with this, with this, with this, we have more than 80% of renewable power in our electricity matrix today. Still, hydro is the main installed capacity today, but there is a projection from Bloomberg to 2050 showing that there is a possibility that in 2050, in terms of installed capacity, solar will be the first one. So we have today 34 gigawatt. In 2050, there is a possibility to have 121 megawatts of solar, and 32% of the matrix. Hydro, 30%, the second one. Wind, 14%. Natural gas, biomass. So this matrix is expected to be 70% larger than this one in 30 years. We're going to experiment a very strong growing of our installed capacity. And it happened very fast. All the solar that we have today, it happened in 6 years. It was extremely fast. So this is energy transition in Brazil. Also, if you take a look at wind, it was also very fast, 10 years. We had almost anything, and now we have 30 gigawatts almost. And this is onshore wind. We have a very big potential for offshore wind. Just last week was approved the law that allows the exploration of offshore wind generation in Brazil. So the situation is that you may have more generation than consumption. So you can help the decarbonization of other sectors, the industry, the transport systems as well. And also, maybe you can export energy, maybe as a green hydrogen. So Brazil, everything indicates that we're going to have a very important role in the energy transition. We'll have a protagonism, a very important protagonism in the next decades to help other countries to decarbonize as well. So another aspect about we are talking about the SDG number 7, clean and affordable energy. So it should, energy transition should be fair and for all. So this is a big problem for the planet because we have more than 700 million people in the planet with no access, especially in Africa continent. In Brazil, we have 1.2 million people in Amazon with no access, and we have maybe 3 million people with precarious access, just a few hours per day using diesel. So we have also energy transition to do in Amazon to substitute diesel and to provide more reliable electricity to these communities. But the big problem in terms of access to electricity, it's happening in Africa, but this is also part of the energy transition. So in our group, we have also done some projects of indigenous communities in Amazon. replacing diesel. This was done during the pandemic. Some students from our group helped to design and to install and to train people from the community. And we developed some off-grid systems for the healthcare center in the community because they couldn't store the vaccines during the COVID pandemic. And now you have also a project with FAPESP to research how we can introduce these renewable energies technologies to the traditional communities in Amazon, respecting their culture and also helping them to develop their business and so on. And also training is very important. In Amazon, we have a very complex logistics to transport equipment and also people for maintenance. So in our project, we will also include training for local people so they can do some maintenance and keep the systems working. So there are a lot of revolutions then. Distributed generation is one of them. The revolution of electric mobility is another one. Also in Brazil, it's still at the beginning, but as you saw, maybe it can accelerate in the next few years. Energy storage, battery systems, green hydrogen. There is a very big potential to Brazil on this topic of green hydrogen. The data revolution, also digital network, smart consumption, IoT platforms, data science, artificial intelligence, all of the subjects here of the conference. So decentralization, decarbonization, digitalization, democratization. This is the 4D of the electric sector. The most common is 3D, as the democratization talks about the fair energy transition. And another challenge for us in the university is how to train professionals for the energy transition, how to modernize our curriculum, because the technology is changing very fast and our curriculum doesn't change. It's very difficult to change. And if you don't have the professionals, there is no energy transition as well. So in this picture from International Energy Agency, it's talking about this energy shift, the employment shift from coal, oil and gas, to energy efficiency, to renewable generation, to low emission mobility, smart grids, bioenergy. So you need to train new professionals in the university for the energy transition as well. How's my time, dude? Okay. So I talk a little bit about the sustainable campus. We tried to do all the things that I just was talking about inside our campus. This is, you should, the university, I think, has this obligation to show, to develop models, to do first, because we have the knowledge, we have the capability to start partnerships, public and private partnerships. So it's easier for us to do this. And we have been doing this in UNICAMP for the last 6 years. But we want to do everything at the same time. We want to improve the infrastructure of the campus, but also improve teaching, researching, and with the goal to transform UNICAMP into the largest living lab on sustainable energy in Latin America. So we want to improve our operations in the campus, but also use the projects to train new professionals for the energy transition. So we have been doing this for 6 years, and now we have a big group of students, researchers involved with several projects on the subject of smart metering, PV generation, energy efficiency, use of IoT for energy management, training and knowledge management for energy transition, building, labeling, also energy contracting, electric mobility, communications, infrastructure for smart cities, We have also a project with public schools, try to introduce the subjects for kids on the schools. We have a project on microgrids. We have projects during the pandemic also in all of our hospitals. I have 5 hospitals inside the campus, and they did a lot of projects related to energy efficiency to all these hospitals. Also, a public lighting system. We have a project with to modernize the system. And in 2022, we created CPTEM, this São Paulo State Research Center on energy transition. The objective is try to propagate this type of actions to the cities, to the municipalities, to the state's administration, and also to the federal administration, try to contribute to the society outside the university. This is our public light system. Now we have a new project. We'll decrease the consumption here in 70%. This is the smart meter platform that we developed to monitor the consumption in all the buildings. This is the electric bus project. Professor Madison was the coordinator. And I think you had experience with the bus today. This is a project with natural gas. All these projects with private companies. Comgás is the gas utility here. Before this network, you had liquefied gas from petroleum in tanks, so you need to transport using trucks and diesel. Also, we had diesel furnace in our restaurant. Now we replace all of this for natural gas. With this project, we're saving 500,000 reais per year with the gas account. Also, we decreased our emissions in more than 10%, and also decreased the risk for the communities. This is our hospitals, and we had big tanks close to the hospitals. Now we don't have it anymore. Close to the restaurants, we don't have it anymore. So natural gas, it's also important fuel for the energy transition because you need energy security. You need energy for today and for tomorrow. We have also a project with our student housing. With a group of students, we developed a lot of actions to the renovation of the student housing so that it could become a sustainable neighborhood. So we have projects on several infrastructures, but in terms of electricity, we could make the neighborhood, the housing, zero energy. We could produce all the electricity that we need, but we also developed some projects to decrease the consumption in 50% with energy efficiency. And the other 50 you could produce locally. We have also a big project here on microgrids. Microgrids could be a solution, for example, for isolated systems in Amazon. So we're replacing diesel and incorporating renewable energy and also energy storage and energy management. And also, if you have wind, you can include wind. If you have diesel, you can keep diesel for security as well. And you can develop some EMS, energy management system to control all the situation in autonomous mode with no operator and with remote monitoring. For example, could be a solution for Amazon. But nowadays, it's a good solution for critical applications where you need very high reliability. You can also think on microgrids. We are developing 4 microgrids. One of these is inside the campus grid. You're going to have diesel, we already have, electric bus, PV, and 500 kilowatts of peak load. And you have also 100 kilowatts of gas generator, more PV, and a big battery container, 1 megawatt, 1.27 megawatts hour. And parts of the campus, this part, will become immune to blackouts. If you have a blackout outside, you can operate the microgrids in an autonomous way by using intelligence of software, no operators. So some details about the components. And we have an optical fiber network to connect all the data to the microgrid control center. Here you have servers with redundancy, and you have the EMS managing all the components. You can control the load, you can control the gas generator, the battery system, even the PV generation. You can control this if necessary. And for the future, we are trying to articulate another project, the Green Energy Hub. UNICAMP has a farm now. This is the land for the HIDS project. The president talked about this, the International Hub for the Sustainable Development. But part of this land, we are planning to install a power plant, but we want to use this also for R&D. We want to introduce here several challenges in terms of energy transition as well. So one, it's an agrivoltaic concept. We want to produce food and energy at the same place. And we want to collect rainwater from the panels. We want to use the residues, the waste from the agricultural production to produce biogas. We want to produce part of the electricity to produce green hydrogen. We want to introduce a hydrogen bus in the campus. UNICAMP is providing the land and also part of the money to construct the power plant. And we are talking to partners to start the R&D projects on several aspects, including this nexus on energy, food, water, and urbanism. This is a kind of solution that could be replicated for small farmers close to the cities who would receive solutions like this. This is the place of the power plant. We have a preliminary project. The projects are done by students, so we're also training at the same time. And of these actions, UNICAMP has been ranked in very good positions in several international rankings, but this one is the THA Impact ranking, the UK rank, in 2022. Looking at the SDG number 7, we were 11th in the world among 1,300 universities with this work on energy management inside the university. So, 5 minutes for the CPTEM. So this is São Paulo State Research Center on Energy Transition. Now we want to try to do this outside the campus. We developed this expertise, energy management for large public customers, something like this. So you can replicate this to other universities or to cities, small cities with the size of our campus. We have 50,000 people in the campus. More than 5,000 cities in Brazil are smaller than 50,000 people, the population. So there is a big potential to replicate. And we have 8 thematic axes. The first one, artificial intelligence and data science for energy management. We want to contribute to the administrations, developing intelligent software that could help to manage electricity bills, electricity appliances, could help them to do some energy audictions and to prioritize investments on energy efficiency, on energy generation, so on. The second one, we have lawyers, because we need also to help the administration to find the financing models and to facilitate partnerships. So regulatory innovation and financing models and partnerships for the energy transition on the public administration. Then you have people working on public policies and governance. You have people of economics studying different scenarios for energy transition in Brazil. Education, training, and capacity building for socio-environmental sustainability. So you have a team experts on education. Then you have technological access, transition to renewable energy and bioenergy, transition to digital networks and intelligent consumption, and innovation for smart counties, including also here, rural areas. This is why you say counties and not cities. The rural areas of the municipalities, they may have an important role also for the energy transition. One example is the agrivoltaic. We have a book with part of this history. We have this in Portuguese and Spanish by now. It's free, you can download. There is a plan to translate also the book to English, but by now we have Portuguese and Spanish. Thank you.